Okay, so we are looking at lesson 4 and 5 here. So we're going to talk about single replacement reactions and double replacement reactions today. So if we look at a single replacement reaction, there's something really important here called the activity series. It's basically a hierarchy of elements, including how reactive they are. This is going to help us figure out if one of these reactions will actually occur or not. So we're going to need to learn how to read this and use it so that we can use it to kind of decide if a single replacement reaction will occur. So if we go ahead and look at lesson 4 here with this activity series, we will kind of treat these in two different ways. If they're going to occur, we're going to write the products in balance. If not, we're going to just write NR. So this is our activity series. On the right here, it's this table. From bottom to top, it goes from least to most reactive. So the ones at the top are all powerful. Those at the bottom are not. Okay. So if we look at this one, single replacement reactions, what we're looking for is we're looking for the one element, so the metal, and the other metal, okay? We need to see if it's possible for this sodium to come in and kick out the copper. In order for that to happen, it needs to be higher than it on the list. So I'm going to look over here on the list. Here's copper. Sodium is up here. Sodium then is more reactive, which means that it can go ahead and do that. So that means I'm going to proceed and keep writing out the reaction. So sodium is going to combine with sulfate, and then it's going to just be free copper because it kicked it out of the compound. So in order to balance that, we just needed 2 right here. Let's look at this one. So we've got calcium and iron. We need to see if iron can come in and kick that out. So I look over here, I'm looking for calcium is right here, iron is right here. Since calcium is higher, it means it's more reactive. That means calcium is going to stand its ground, and this will not occur. Okay? So be comfortable reading that and deciding if you can use that for a single replacement reaction or not. When we get to lesson 5 here, we're looking at double replacement reactions. So there are 3 guidelines for double replacement reactions to occur. You need at least one of these in order for it to occur. So one product is only slightly soluble and precipitates. That means it's going to stay as a solid. One of the products could be a gas, or one of the product is a covalent compound such as water, and that will allow it to occur. So first thing we need to be able to do, though, is look for these solubility rules to figure out if number 1, the first of the guidelines, will happen. There's a table that we're going to use. This table is a little tricky when you first start reading it. The first half means that these things are soluble, so that means that they will not precipitate out, okay? Except if it has any of these combined with these, then it will precipitate out. This is the reverse. These will always form precipitates, except if it's these combined with these. Okay, so we're going to practice reading this. So what I would look for in here is you're always going to look for that anion. So in this one, we have the sulfate, or the sulfide ion, excuse me. So I look and I find it on the table. It's right here. It says that it's insoluble unless it contains 8 NH4 alkali metals. That's the first column, along with sodium, calcium, strontium, barium. Bottom line, we have silver, which is none of these, so we don't have an exception making it insoluble. So I'm just going to label that with an I. That means it would form a precipitate. So if that helps you to think about that, I'm going to write down precipitate, so PPT. Calcium chloride, so I'm going to look for chlorine right here. It all is soluble except if you have silver, mercury, or lead. We don't have any of those, which means we're going to follow the directions, which it's soluble, meaning no precipitate will occur. Last one here, we've got lead bromide. So if we look here as bromine, silver, mercury, lead plus 2, that's what we have. That means we have an exception. We've got this exception right here, making it the opposite of what it says. So that would be insoluble. And again, that means precipitates formed. Okay? That's how we deal with that first guideline. What's important, though, is we need to be able to write what's called net ionic equations. It's going to show us essentially what's happening overall in a reaction when we have a double displacement reaction. So the first thing we need to do here is be able to write out what's called the total ionic equation. We're going to basically break everything apart into its ions, and then we're going to move from there. So this first example we have is silver nitrate reacting with sodium chloride, forming silver chloride and sodium nitrate. So we're going to break these apart into their ions. So we're starting off here, we've got silver, so I'm just going to start writing these out. So we've got silver plus 1. Keeping these phases is really important. That means it's aqueous, meaning it's in water, it's not soluble. So NO3 is aqueous, okay? We've got sodium Make sure you keep the charges with them. Okay, and then we've got AgCl. Whenever you see something that's not aqueous, you cannot break it up. Because this is solid, it needs to stay exactly as is. So it just gets recopied right here. Okay, it doesn't get changed. And then we've got sodium and plus nitrate. Next thing we need to do is identify spectator ions. These are ions that are going to be here on both sides, so they're not going to be written in what's called the net ionic equation, which tells us the root of what's happening. So we look up here and we see, okay, does anything look exactly the same on either side? Well, the silver is now with chlorine, so it doesn't look the same. This looks the same. So here it is here and here, here and here. Chlorine again is with silver. So any spectator ions we have, I'm going to write them down, are nitrate. I'm just going to make this say and sodium. Okay, so what we're going to do now is we're going to write the net ionic equation. To do that, we're just going to cancel spectator ions and write what's left. So I'm going to go back up here. I'm going to cross them out. So we found the spectators. I'm going to cross them out, and they won't get rewritten down here. So what's left we have is silver, chlorine, forming, I should say chloride, forming silver chloride, and that's it. So there's another example here that you can go ahead and give it a try. Your net ionic equation should have lead and sulfate forming lead sulfate. The only thing in here, whenever you have a coefficient out front, so like this 2 here, that would get written out as 2H plus 2 nitrates. Remember that goes to each. Also know that this 2 after the nitrate is going to come out in front. It's going to basically tell you how many of each thing there is. Okay, so you can go ahead and give that one a try. And the spectator ions you should find would be nitrate and hydrogen.